Hello students, in this class we will see pair of linear equations in two variables, concepts and its introduction. Okay, let's see what do you mean by a linear equation in one variable. Before that, before we come to linear equation in two variable, we have studied this ax plus b equal to 0. It is a linear equation in one variable where x is a variable, right? What is the solution for this? X equal to minus b by a is a solution or a 0. Now let's see the linear equation in two variables. Ax plus by plus c equal to 0 is a linear equation in two variables where a, b, c belongs to real numbers. What are the variables here? Variables are x and y. Okay. Why it is called linear? Anybody guess? Because the power is 1 for variable here, therefore they are called linear equations. Remember that based on the power of the variable we classify the equations as, if see, if degree of variable is 1 it is called linear, if it is 2 it is called quadratic, if it is 3 it is called cubic, right? Degree or power of variable. So linear equation in one variable is ax plus b equal to 0 standard form, and in two variables it is ax plus by plus c is 0. Can we find a variable value here directly? Just like here we found for one variable. No, we cannot find answer values for x and y because they are two unknowns here. Okay, remember that. So this is a standard form of a linear equation in one variable. What pair of linear? See the chapter name, pair of linear equations. What do you mean by pair? Pair means there will be two sets of linear equations. How do we form that? See, it is like this. A1x plus B1y plus C1 is 0. A2x plus B2y C2 is 0. Okay. These are the pair of linear equations in two variables. Why do we say pair? Because there are two linear equations in one variable here, where a1, a2, b1, b2, c1, c2 are the real numbers for the equations. X, y, they remain same. Okay, that's why it's called pair of linear equation in variable. These two can be solved now to find the x and y. We have different methods of solving these two equations. We'll see in the coming classes. But to know the knowledge of a pair of linear equations in two variables, this is the standard form of linear equations in two variables. This is a single equation in two variable. It's a pair of linear equations in two variable. Okay. Now, based on the, see, we have seen the equations as a1x plus b1y plus c1 is 0, a2x plus b2y plus c2 is 0. Let's take the example that x plus 3y is equal to 6, 2x minus 3y is equal to 12. Can we extract a1, b1, c1, a2, b2, c2 comparatively these two? Yes, we can do. A1 is 1 because x coefficient is 1, B1 is 3. Okay. What is C1? C1 is 6. You may ask, everything is in the standard form, it is at the left side, but we have a variable a value in the right side. You just rearrange it. It doesn't alter the ratios, which we'll be seeing in shortly. We'll arrange this also as like standard form. 2x minus 3y minus 12 minus 12 equal to 0. Okay. In that case, C1 becomes minus 6. Similarly, A2 is 2, B2 is minus 3, C2 is minus 2. Okay. These values are got by checking these two equations, not the middle one. Now, we have to learn few properties here. Like these two equations, when they're given, linear equation two variable, what is the number of solutions they have? How does they look when we graph them? What are the what are the type of linear equation solutions here? Whether they're consistent, real, or no real roots, or dependent and real, distinct, infinitely solutions they have or not, or whether they do not have solutions at all. So we need to understand those concepts now. How do we understand? We have certain rules for that. Please memorize these rules. I'll tabulate them later after explaining, but please try to understand these concepts. This will be very tricky concept. Okay, let's see. When a1 by a2 not equal to, sorry, b1 by b2, when a1 by a2 not equal to b1 by b2, we have 3 points to remember for each of the ratio. What are the 3 points? When the first a1 by a2, b1 by b2 not equal, then the solution type is consistent. Remember that solution type is consistent solutions they will have. Okay. And how many solutions they may have? They will have only one solution. Only one solution. The type of solution is consistent. They will have only one solution. How does the line look when we plot them on the graph? They look intersecting. They look intersecting at one point. Okay? Intersecting means if you draw a graph for these two lines, we'll be seeing in next class or probably in this class. When we draw, okay, what is the type of line for a, what is the type of graph for a linear equation in two variable? We saw in previous class, it's a straight line. Okay, so for example, if I draw for first line equation and second one, so this is the solution. This coordinate is the solution. So basically, they will have one solution because they intersect at one point. They are intersecting lines, and the solution type will be consistent. This is for when a1 by a2 ratio not equal to b1 by b2. Okay, I'll recap this. This is very important. When the ratio a1 by a2 not equal to b1 by b2, we need to remember 3 points. They will have one solution. They are intersecting lines when we plot them in the graph. The type of solution will be consistent. Let's see. Well, how does these look? Can we find that a1 by a2 for this example? If we take up a1 by a2 is 1 by 2. What is b1 by b2? 3 by minus 3. That is again 1 by 1 only. 3 1 ja 3 1 ja minus 1. A1 by a2, this one. B1 by B2 is this one. For this solution, for these equations, Does any of these holds good? No. Yes, because if you see a1 by a2 is 1 by 2, b1 by b2 minus 1. So they're not equal. So that means when we plot these two equations graph, we get intersecting at one point in the graph. They will have only one solution. Their types of solution is consistent. Okay, let's write that here. See, if a1 by a2 not equal to b1 by b2, okay, if a1 by a2 not equal to b1 by b2, how many solutions they will have? Only one solution. What is the type of lines here? Intersecting lines, right? I'll just write x and word intersecting. Please take a note of this table. Very important. Intersecting. What is the type of solutions? Consistent. Okay. No. We'll move to the next ratio here. Okay. Let's see the next part. If second one, if a1 by a2, we have seen the a1 by a2 not equal to b1 by b2 condition. Now if you see a1 by a2 equal to b1 by b2 equal to c1 by c2, means the ratio of all the constants, coefficients a1 by a2, b1 by b2, c1 by c2 ratios, if they are equal, remember that first case not equal, one solution, consistent, intersecting lines. Now, three ratios not equal. Okay, this is the second condition. What does that mean? It will have again three types, same similar way. This is consistent and dependent and consistent. Dependent, dependent and consistent type of solutions. How many solutions they will have? They will have infinitely many solutions. Infinitely many solutions or infinite solutions you can say. Okay, here then the last one is how does the lines look when we plot them in the graph? They look coincident. What do you mean by coincident? Coincident mean when you place one object on the another, they overlap themselves, leaving nothing. They look similar, alike. They're called coincident. Means when we draw a line, one line, can we draw another line on the coincident such that that second line is coincident? Yes. How? The same as the line we drawn here. It will not deviate its positions points at all. They are called coincident lines. How do we represent two coincident lines? We represent by two arrows such that one pair of arrow is one line, another pair of arrow is another line. Okay. Remember why they will have infinitely many solutions? Because when do we say how do we find a solution means when a graph in a graph this suppose is a graph for some line, this suppose is a graph for another line, how many solutions this graph has without knowing any knowledge, what is how many points it intersected the each other, that is the number of solutions. So one point it intersected, so one solution. Now since they're coincident means every point on one line touches every other point on the other line, so it is infinitely many solutions. How do you say? Because a line is made up of infinite solutions, right? Infinite solutions. So remember, when the ratios are equal, a1 by a2 equal to b1 by b2, c1 by c2, all three are equal means they will have infinite solutions. Type of solutions will be dependent and consistent, and the lines are coincident. Okay. This example will not come because we saw A1 by A2 not equal to B1 by B2 here. So they will have only one solution here. Okay. Now let's see what is the example for this. Let's see. Let's take out a few one another example here. See 5x minus 8y plus 1 equal to 0. The other one is 15x minus 24y plus 3 equal to 0. Okay. Let's find the A1 by A2 ratio. A1 is 5, A2 is 15. Cancellation gives 1 by 3. B1 by B2. That is always take with sign when you extract ABC values. Okay. 8 by minus 24 is again minus minus cancel. 8 1 ja, 8 3 ja gives 1 by 3. Right. C1 by C2 is what? It's directly 1 by 3 because C is 1. So all three ratios, if you check, they're equal. So when we plot these two lines, they will come coincident one over the other on the graph. That means they will have infinitely many solutions and the solutions will be dependent and consistent. Okay. Can we make a table? In the second one, if all three ratios equal, right? A1 by A2 equal to B1 by B2 equal to C1 by C2. Number of solutions is how many? Infinite. Remember, infinite solutions. How does the line look when we plot them? They look like this. So that means coincident lines. Type of solutions dependent and consistent. Dependent and consistent. Okay. Here we have another case. We will see that third case is when A1 by A2 equal to B1 by B2 not equal to C1 by C2. Okay. When A1 by A2 equal to B1 by B2, that is not equal to C1 by C2. In this case, what are the 3 points to remember? What are the 3 points? Here, what is the type of solution? It is inconsistent. Remember this, inconsistent. They do not have consistent solutions. Then, how many solutions? No solution. No solution or zero solution, you can say. How does the line look like? They look like parallel lines. Parallel lines. Since the lines do not intersect at all, so we will not get the solutions at all. So the lines will be parallel. Lines will be parallel. We ourselves can construct equations here. Okay. Let's see. X plus 3y minus 6 equal to 0. First two equations should be, ratio should be same, right? So I'll say 3x plus 9y minus 4 equal to 0. Another one. There is a question in the exercise. Construct two lines, linear equations, such that the lines are parallel. Maybe lines are coincident. Lines are intersecting. You should know the ratio. How does this ratio, based on the ratio values, we decide these 3 points. Okay. Can we find A1 by A2 here? A1 by A2 is 1 by 3. Means this and this x coefficient are A1 by A2. What is B1 by B2 is 3 by 9, that is 1 by 3. Okay. B1 by B2 is 3 by 9, 1 by 3. Then C1 by C2. What is C1 by C2? Check out. Minus 6 is C1, minus 4 is C2. minus minus cancel, 2 2s are 2 3s are 3 by 2. So here in this case, A1 by A2 is equal to B1 by B2, right? But not equal to C1 by C2. That means these given equation fall under this example where inconsistent solutions, parallel lines, no solution. Okay, let's form the table. So third one. So how does that look in the graph means here? The first one, so the lines will intersect like this. In the second one, this if it's a coordinate parallel, sorry, consistent, right? In coincident, right? So it will like this. You will understand when we plot a graph taking examples. Third one, see. What is the ratio we just learned? A1 by A2 equal to B1 by B2 not equal to C1 by C2. Then number of solutions is 0. Remember that. Type of lines. How does they look? They look parallel lines. Parallel lines. When we plot in a graph, how do they look? Maybe like this. Or it may come down also. Okay. Anywhere. Parallel. Not necessarily horizontal. It might be vertical also. Okay. So basically parallel lines. Since they are parallel, they do not intersect. So zero solutions. Remember, I'll give some clues post this. How to remember these 9 points based on the ratios. Okay, what is type of solutions here? Inconsistent. Inconsistent. Type of solutions. Okay, this is very important table. Okay, this is very important table. You have to remember this table somehow. How do we remember? If the first two ratios not equal, then we say intersecting. One solution. Please by heart that or try to remember in the order I explain. If the two ratios are not equal, first two ratios not equal, means intersecting line, one solution. When we have solution, it means it's consistent solution. Okay. When the all the ratios equal. First case is when two ratios not equal. Second case is when all opposite of that. What is that? Equal, right? Not equal, opposite is equal. So we take all ratios are equal, all three ratios. Then the lines are coincident, one over the other. When one over the other means you have to remember every point is a solution. Every touching point on the lines is a solution. So it will have infinitely many solutions. Lines will be coincident. Since they have solution, type of lines will be solutions will be dependent and consistent. Then first two ratios equal and that is not equal to third ratio. Remember, third case is a little different from first two. First two equations, first two ratios are equal, which is not equal to third ratio. Then the lines are parallel. When the lines are parallel, like this or this, they will not have any solutions at all. Means zero solutions. Type of lines will be parallel lines. Type of solutions will be since parallel lines, they they will have inconsistent solutions. Remember that when we approach the exercise, we need this table throughout the chapter. Okay, practice well this introduction part, this table especially, which is very important. Okay, thank you.